Hello. Okay, so last time we had a weapon system working, and that is pretty much done now. We can pick up various weapons. We've got the sniper rifle, I can pick up a shotgun, I can pick up an Uzi, and I can also right click to switch between these things. So that's nice. This time I want to add an enemy that has a vision cone so that we can do some stealth type mechanics. Basically just an enemy that can detect you or not detect you, and that way you will have the tools you need to build a stealth game or an action game if you want to, and then also B, I have an idea of how to mash those two things together that I'm curious to see if it will work. Basically I'm thinking about a game where there's a stealth phase and an action phase, but you have to do both. Because one of the problems with blending stealth and action is that you end up doing a lot of work to make two games, and then the player really only does one of them if they're a stealth player, because as soon as you get detected, you just give up or reload. So we want to fix that. I'm just going to delete all our enemies, because the big cube enemy, that enemy type is not really going anywhere. In that it's not getting interesting. It is going somewhere and I've deleted it. And I'm just going to create a new one. And I'm going to do something we should have been doing all along, really, but I didn't. Which is to create an empty game object first. We did this for our enemy spawner, we did it for our weapons, and ideally we should have done it for our player and our enemy, but we didn't. I didn't want to overcomplicate it at that point. I'm just going to call it guard. And it's empty so we can't see it. We should be in scene view so that we can at least see where the anchors are and stuff. Let us... I'm just going to change this Y coordinate to 1. Is that right? Does 1 look like it's on the floor? No, it's not on the floor, is it? It should be 0.5, which is really dumb. Yeah, that is on the ground. I wonder if... Let's change our ground level. Okay, this is a bit drastic, but okay, I've put the guard on the floor. I'm just going to select everything. Can I do that? I'm just going to Control A. Oh, I can't move them all at once though. I can move nearly all of them at once. I'm curious as to which thing stops me. Oh, the canvas, of course. Canvas is like a UI thing. So, what I want to do is like. You can drag them all like that, but I can't see what the value is. Or can I? Is that going to work? Why is the player in the ground now? Didn't I move everything all at once? Okay, forget that. Sorry. Let's just move the ground down. So the issue is like, the ground is at 0. It sounded logical at first, but it actually has height, and the 0 is the middle of the ground. And so its height extends 0.5 units up from there, and that means everything else has to try and align itself to 0.5, which is silly. I would like that to be 0, and therefore I should just put the ground at 0.5, minus 0.5. And actually, if I just do that, everything's fine, because these walls are tall enough that that's not creating a problem. You can move all these walls down as well if you like, but I am fine with that. I don't really need the weapons to be lower. I will move the player down to 0.5. So his coordinate will be weird because we didn't use an empty game object before creating him. We could do that, but I'm not going to do it right now because it's distracting. So now our guard can just be a 0, and that'll be exactly on the ground. And then I'm going to, I think visually they should look like a cylinder, which is a kind of humanish shape. The cylinder's Y coordinate is going to be 1. I right-clicked on the guard when I created the cylinder, which means it's a child of the guard, and that means the guard can stay at 0, and anything to do with the cylinder's height that gets weird or complicated will just be on that. And what else does it need? It needs a enemy behavior. I'm going to modify enemy behavior. Give them speed of like, leave the speed at 0 for now actually. Enemy behavior, they'll need a rigid body, which is the sort of physically part that lets them move. And a health system, because otherwise we won't have any health. We can give them like 10 health. A health system needs a reference to the health bar prefab, which is down here. Drag that in. Yeah. So yeah, this guard is going to behave differently to other enemies, and for now I'm just going to modify our enemy behavior. I'm going to change it in ways that suits the guard and doesn't suit the previous mindless kind of enemy type. We are going to keep that mindless kind of enemy type, but the behavior we're about to make has a lot in common with them. And the behavior we're about to make is more complex. And so I want the enemy class to support that kind of complexity. And then when we come to restore the mindless enemy type, we will make a kind of subclass of enemy that just doesn't have some of the special features of this one. All of which is just to sort of prep you for the fact that we are going to break our old enemies for the time being, and that might seem like a weird way to do it. We could just copy and paste the enemy script to make a whole new one that suits this. You can do it that way. It's just that then if you change things about, let's dig into enemy behavior. If we change things about like how it seeks the player, things like that, that's the kind of behavior that we want to be shared between a guard and a mindless enemy. The guard should only do it when they know where you are. The mindless enemy is going to do it all the time. They're going to, those enemies will be flooding in when the alarm has gone off, so everyone knows where you are at that point. So yeah, all this code is them seeking towards you and checking for whether the player's null, and when they touch you, it hurts you. All that stuff is going to be common to both. But our new enemy is going to have some extra functionality. And basically it's easier. You kind of want your, well, we'll get into parent classes and extending things and subclasses and stuff when we get to it. For now, we're just making the enemy class more complex, and because of that, I'm just going to go to our enemy spawner and disable it. I don't want it to spawn any enemies yet. We could have it spawn guards, but that's kind of weird. My idea for the basic sort of format of our game is you'll start in an area with some guards looking for you, and you'll try and steal some weapons, and then if and when they detect you, all the mindless enemies will flood in, and then it'll be an action game from then on. And if you manage to get all the weapons without being detected, then you just open fire and you trigger that onslaught. Your goal is to actually have the onslaught happen and wipe them all out. That's roughly what I have in mind. So, what does the guard need? I want to put a light on them. So I'm going to right click and go to light and spotlight. Yes. And that'll be created as 0, 0, which is kind of nice. I do want it to be in him. I'm going to move up a tiny bit. And its intensity is not very bright yet. If I increase that, you'll start to see it on the ground. Let's get the camera above it so we can see. And this light is going to represent the vision cone. So in gameplay logic terms, we want the enemy to be alerted if the player enters their cone of vision. The light is not going to do that. The light is not going to detect anything, or it's just a light is just a visual effect, so it's not going to have any gameplay logic attached to it. But it's going to represent where the vision cone is. We need to communicate to the player where this enemy can see. And the nice thing about doing that with a light is that you get occlusion for free. So if there's something in the way, the light will be stopped by the object, and so will the guard's vision, and so those things will stay in sync. If you try and draw it as a UI element, and you try and draw your own cone or sprite on the ground, that kind of occlusion gets tricky. It's a more advanced thing to do. I wouldn't want to do it in a tutorial. So light is a nice cheap shorthand for this, and also it just looks cool. Dynamic lights, if you had like hundreds and thousands of them, they'll start to slow the game down, but it won't matter for our purposes. We're going to have like 8 guards in a room, so it's fine. Okay, so I made it more intense so we can see it. It's very narrow, isn't it, for a vision cone? Spot angle is going to be the thing that changes that, and something like that looks pretty good to me. It's also a little bit hard to see just because the whole scene is so bright. So we can take our scene came with a directional light. It's a bit confusing because I would intuitively want to call that a directional light, and then there's this thing that's illuminating the whole scene, I'd call that like a global light. That's not what it's called. Directional light actually means the light is coming from one direction. That sounds really facile. But what it means is like the left side of everything will be light, and the right side of everything will be dark, no matter where they are. Whereas a light that has a specific source is going to not have that. I think that's right. That's right. Anyway, our scene came with a directional light for free. It's kind of to simulate the sun, basically. And we can just turn it off completely. I wonder, let's just try reducing its intensity. So if we let it be like 0.18, I quite like that because then we still get some shadowing. If it's gone completely, then yeah, you still do get some shadowing, but it might just be nice to kind of pick things out a bit better. Now, what would happen if we just ran the game right now? Let's try it. Okay. The guard does not move in any way. Oh, now they do. And now they're spinning. Oh, that's because I just brushed into them. I can knock them around. Okay. That is interesting. They're not moving because they have no speed. And then the other thing is that currently enemies don't face the player. So, because our other ones were just kind of rolling physics objects, we didn't try and change their directionality. So even though you could tell they were coming for you because they were coming for you, and that gave them, you could read their direction from the direction of movement, but actually they were never turning to face us. We didn't make them do that. But we can, and we know how to do it, right? It's transform.lookAt. It's going to be the player's position we're going to look at, but now that I think of it, we're going to be using the player's position a lot. So I'm going to define, up here, just before we say vector to player, I'm going to define a new vector 3, and just call it player position. And that is going to equal this thing, references.theplayer.transform.position. It's a 4-element term. And although hopefully we all understand what this says, it's all familiar stuff. It's just very long, so I just want to shorten that by saving it to a variable that we can then use. And now, like, even this part is more readable now, right? It's vector to player is player position minus our position. And transform.lookAt, player position. So rather than have to write out that 4-element term again, I can just use that. And we're going to use that a lot more, so it will pay off. So hopefully that will have them just sort of look at us. Yeah. Yeah, that's kind of cool. Yeah. The fact that I can knock them over like this is... Oh, that hurts me to do that. Shall we... Let's freeze their position and rotation in some axes. So if you remember, they need to be able to rotate around Y. That's the pole going through their head, like they're on a carousel. So freeze rotation in the other 2 dimensions, and then freeze position in Y. I don't actually know if that stops us from knocking it around. It might not. I don't know which thing takes priority. No, it doesn't. Oh, well, never mind. It's worth doing anyway, because we don't want their own motion to have them fall over or anything. So we should do that. Okay, what is next? So I would like to... Let's get the actual detection logic in. First, so we can see it a bit better. This is roughly where the game camera is, right? If I switch to game, yeah. I'm just going to move the enemy a bit closer to the camera. One day we'll have a camera that moves with the player and makes sure everything is always in focus, but for now let's just do it this way. And in the enemy code, let's just I want some public floats to represent so that we can tweak how big their vision cone is and its dimensions. So public float, let's say vision range, and public float vision cone angle. And is that everything? Yes, for now. And now all this code actually says follow the player. We don't want to do that unless we detected them. So let's write this. Let's give ourselves a boolean for alerted. Public bool alerted. So we've used bools before, right? Bool is short for boolean, which means a yes or no value, a true or false. And then on start, alert is going to be false. So hopefully that all makes sense so far. We haven't used vision cone yet. And this means, the reason I did that is so that I can now say if alerted, then we'll follow the player. but not before. So if we're not alerted, we should look for the player. And to do that, we want to know, first of all, I'm going to move this player position and vector to player. Those are going to be useful, so I'm going to move them up here. So when you declare a variable, its scope, the realm in which you can use it, is where you defined it. So if I define it within that if statement, I'm just going to go back to how it was. When it's defined in there, I can't use it here. If I start saying player position, no, doesn't autocomplete, doesn't know what I'm talking about, because we defined it in here, so it can only be used in here, in that highlighted area that I just highlighted. And actually I want to use it in both branches of whether you're alerted or not. It's going to matter where the player is. So before we get to alerted, let's define it up there. And in fact, that's a perfect place for it, because that's right after we checked whether the player even exists. And so as soon as it does, we get those useful variables we're going to use all over the place. And it's kind of nicer as well, just because this follow code now is just 3 lines. We've separated out things that aren't actually the follow code. And in fact, let's simplify even more while we're at it. This rigid body thing, there's no reason to be establishing a reference to our rigid body every update, right? We're in update here. We should just do that on start. So I'm going to, if I paste that up there, that doesn't quite work because rigid body does not exist in this context, because we declared it in start. That means it only exists in start. So we want to declare it up top. I'm going to copy this, just put it there. We don't need to set it there, and then in start we set it to our rigid body equals get component rigid body. Okay, so now our follow code is only 2 lines, which is very nice. It's quite satisfying doing this. And if we're not alerted, that's when we want to get into looking for the player. So let's do that as a comment fact. Look for, oh, actually we're not looking for the player. We are checking if we can see the player. There won't necessarily be a searching behavior. We might do that, but we're not doing that just yet. And if we're already alerted, I think the rule is going to be once they're alerted, they'll just seek you forever, no matter how you hide. So we don't need to worry about, basically, once you're alerted, you don't need to keep looking for the player, keep checking for the player. You're always going to know where they are. So, first thing to check is the player in range? We've got a vision range. We want to know if vector3.distance, we can call the vector3 hotline and ask it for the distance between 2 points, and we're going to ask it for the different distance between our position and player position. And what we're interested in is that less than or equal to our vision range? So that pointy bracket is less than, and in case you need a reminder, it's less than because the left side of it is smaller and the right side of it is bigger. It goes that way. I don't know, there's mirroring of the camera examining, that's probably wrong, but the side that's smaller is the side that you're checking is smaller. And then the equals after it is just so that if it's exactly at the vision range, we do detect it. It doesn't really matter whether you have that equals there or not, but it's just sort of I do it because in my head, if you say I can see 10 meters and I'm standing 10 meters away from me, I think you should be able to see me, rather than not being able to see me. But it's the threshold. What's next? We want to know, are they in our vision angle? So we want the angle between 2 vectors. And a vector, remember, can be a position, or it can be like a line in space that's pointing somewhere. So, like my arm is a vector right now. And so we don't want to compare, we don't want the angle between like our position and their position, because that doesn't really make any sense. We want the angle between our forward direction and the direction to them. So I'll do it facing the camera. Let's say we are facing this way, you're looking at the scene from above. I don't know what I'm doing. Like, we have a very visual medium here that I could be using. Let's use that instead. So the question of whether or not the enemy has detected the player is a question of, this blue arrow is forward, remember, Z is forward. So we want to know what is the angle between that blue arrow and the line that would go from us to them, from us to the player. So a line there, which I can't draw easily, but oh, I did have a little drawing program, didn't I? I haven't started that up. And so in this case, what does that angle look like? It looks like maybe 30 degrees. So once that line is 30 degrees off, we would detect them. We don't need to know what that exact number is yet. We're going to tweak that while we're playing so that we can make it match the light exactly. But yeah, that's what we're interested in, the angle between our forward and the angle to the player, which is going to vary. And we actually already have a variable for the vector to the player. So that's one of the things we need. And the other one is just our forward vector. So if vector 3, we're calling the vector 3 hotline again, and this time we're asking for an angle, and it's the angle between our transform.forward, that's our blue arrow, and the vector to the player. Oh, we have to actually check something, don't we? Is that less than or equal to our vision cone angle, which will be set in the inspector? And if it is, then alerted equals true. And the enemy is going to look at us at that point. I guess let's just test that. It's not the most useful way to test the values. Once we get to tweaking the values, we're going to do something different because I want to be able to... this is not ideal for testing right now because after they've seen us, they can always see us. And so as soon as we go into the vision cone, we're going to... we can't check whether we left it or not. So right now, nothing happens at all. And we know what that is, don't we? Because we didn't set any values. So let's give it a vision range of like 10. And I reckoned the angle was 30, didn't I? And now let's see. Hey, at roughly the right time, they started tracking us. And so this is what I was saying about why this is not a great setup for testing. It's nice that it worked, but now I can't tell. That looked to me like it was a bit late to detect me, but now I can't tell. Was it a bit late? Was it just imagining it? And I could tweak this value, but it's too late. It no longer has any effect. So for testing, I just want the enemy to tell us whether they're seeing us currently or not, and tell us if they're no longer seeing us. I don't want them to look at us, and yeah, I just want some visual feedback. And actually, I think we should have some visual feedback anyway for when an enemy has seen you. Their vision cone should turn red, at least. That would be a nice thing. So if we want to turn our light red, we should get a reference to our light. So we need a public light, my light. And we'll set that in the inspector in a minute. And then what I'll do is, I think just right up top here, we'll say mylight.color equals color.white. I don't think we dealt with color before, but color is another hotline like vector 3. You can just call it up and say, give me the reference for white. And yeah, the light is it'll just be a reference to that light. And once you have a reference to light, you can change its color, which is nice. And so when you see us, let's make it color.red. And for now, I'm just going to make this a comment so it doesn't do anything, just so that we always run this code. I don't want that code to stop running while we're testing this. Let's see if that works. No, because I didn't set a reference to the light, did I? I said I'd do it, then I didn't, which is what I do every time. Okay, so under our guard, where we created this spotlight, we can drag that over to the light slot that we created. So yeah, so that word light there, that's why we use the word light when we define this variable. Now, okay, yep. I forgot another thing, didn't I? When I set those vision range and vision cone angles, I hadn't played the game yet, so those are changes made at runtime, and those are not saved when you stop playing, which is annoying, but I remember what they were. So we'll make them outside. In a minute, we're going to make this into a prefab, and then we'll just edit the prefab in future. Okay, that's not bad, actually, is it? Yeah, he should be seeing us there, and so actually, what we can do is, if we move to what's the edgiest place that they should see us, that they Yeah, that they should see us. It's the furthest out of their vision cone we can go where it makes sense that they would see us. I think that looks like they should detect us. So I'm going to stand there, and then I'm going to drag. So you can click on the word and drag left or right to increase or decrease this thing. I'm going to keep dragging right until it goes red. And once it does go red, I'm going to go back a bit until it goes white, and then find that threshold is right around there. It's 34.6. And I said this was a detection angle, so I'm going to make it detect us. And now, what about range? How's our range doing? The range is too high, isn't it? That's, man, for what we're seeing there, you'd be a bit peeved if you got spotted at that range. So, where would be a good range to get spotted from? I might actually, shall I increase this intensity a bit? The intensity is down here, just so we can tell where it ends better. That's extremely strong, but that's good to err on the side of clarity. And now it's much clearer. Oh, in fact, that's pretty bang on what we have, isn't it? I'm going to say, oh, you can actually see me catching the light as I move into it. That's kind of cool. I'm going to say that this range is the closest at which I should be seen. Before then, I shouldn't be seen. And go back to our guard. And remember, all the changes we're making at runtime, so as soon as I stop playing, I'm going to lose all this. I don't want to lose all this, so I'm going to show you how you don't. So I'm going to drag this down until it's not detected, and then put it right on that threshold. I reckon that's about right. Okay, now we've got all these values set up nicely. This is a really good time to make the prefab, because you can do that at runtime just like you can when you're not running the game. So you just drag guard to our project folder, and now the prefab has all those values we just set. So we will actually lose them on the instance we were playing with, but I'm just going to delete that now because we don't need it. And then just drag the guard prefab back into the scene, and here they are. Oh, that's interesting. They've got their light is currently red because they were red at the time we made the prefab. That's fine. And that is working pretty nicely. So we haven't actually done occlusion yet. I was talking about, like, a nice thing about light is blocked by things that block light, and so is vision. We haven't done that yet, and we're not going to do that this episode because it's a little bit more complicated. The visual side of it is easy, but then the actual detection of how does the code know whether something's blocking line of sight, that will get us into layer masks and things. So I'll save that for another episode. But there's more to do here as well, isn't there? Our enemy is not reacting much at the moment. So now that the values are correct, we could allow them to see us. I think I will keep the color logic the same. We could make it so that it's red all the time they've seen you. That would be important in a game where, we might do that anyway, eventually, but that would be most important in a game where individual enemies have different knowledge. In our game, I think once you're rumbled, everyone will know where you are. And that's just a simpler model for us to work with. And yeah, just while we're working with vision cones, I like being able to tell whether the enemy thinks they're seeing me currently or not. So I guess let's just test this. We just restored the look at the alerted thing, which is going to restore the look at behavior. They do look at me, but it's not going red anymore when I'm in their vision. Oh, I know why, because the detection code only runs if we're not alerted. So actually, maybe it should just, maybe I'm going to change my mind on this and just let it be red if we're alerted. We could run the detection code either way, even when you are alerted, but because, like I say, we're not going to let you lose heat. We're going to make it so that you're detected forever. That is not how we'll do it. Okay, cool. That's working. We do have, let's just make a couple more guards. I've selected the guard, I'm going to select him now and do Control D, duplicate, and do it again. Now we got 3. And so yeah, they do have individual detection. but yeah, it's kind of cool. So let's now, from now on, we've got to be careful about, we edit the guard prefab, not the guard instances, because we've got a bunch of them. Actually, it's kind of good to make a bunch of them just so it's easier to remind yourself that you shouldn't edit the instance in the scene, because you can see, obviously, that would be bad. Let's give them a speed of 2 for now. See how that feels. Nothing happens at all. Do the instances have... No, they all have speed 0. That's interesting. But when I stop the game, they're speed 2. Okay, that was just a weird temporary glitch. Unity had not fully saved the prefab, I guess, at the time I started the game. Okay, so now when they... once they know where I am, they start to follow me. That's cool. So the game, the sort of first stage of the game that I envision is that you should be trying to steal these weapons from under these guards. Gosh, that's the rifle. That takes a while to kill him. I've got a lot of health. Shotgun's a bit better. And Uzi's not great. Alright, cool. So the only other thing I want to do this episode is we need some kind of idle behavior, right? Because if these vision cones, right now because they're static, if they're not on the weapon, then it's trivial to take the weapon. If they are on the weapon, it's impossible to take the weapon. We'd rather they were sort of roaming in some way. We don't want to go too deep on this yet, because like proper AI, and I think I can envision a system where there's patrol points and the enemies move between them in some intelligent way. That's beyond the scope of this episode. For now, I just want them to, at the very least, rotate. I would like them to sort of scan like a lighthouse, and that way there's some dynamic element to the level. And that would only be if they're not alerted, right? If they're not alerted, we would want them to look for the player, but also rotate. And our code for facing, let's say rotate here. Our code for facing is this transform.lookAt thing, and we give that a position. So what position should they look at if we want them to rotate? I would say it is, if we tell them to look at a spot just ahead of them, that would be their position plus their forward vector. It would be, I'll write it out because it will form part of what we do. If I can ever select this line. Transform.position plus transform.forward, that just tells us to look in the direction we're already looking. So that doesn't do anything by itself. But that's the kind of statement we want. Like, to make us turn right, what if we looked at the spot ahead of us plus a bit in the right direction? Which would be plus transform.right. So we're always going to look at a spot that's just to our right. Let's see. I know that's not good yet, but I want to see what it looks like. Yeah, that's what I thought. It's a bit fast. You'd be hard pressed to make it through those vision cones. I mean, it's actually optimal guard strategy. I don't know why guards in other stealth games don't do this, because it really rumbles you as a player. So there is no speed to this. So it's actually, to control the speed, I would control... This is going to happen every update, whether we like it or not, is what I was going to say. I mean, we've told it to, so it's going to. What I want to do is scale the offset. So right now, our offset, if I do like, let's call it lateral offset, it's just transform.right. And that's a vector going to our right, and it's of length 1, so it's a meter to our right. So every frame, 60 times a second perhaps, we are looking a meter to our current right, and of course that changes the direction, our forward direction, which also changes our right direction, and we spin around wildly. We want the spinning, but we just don't want it to be quite that fast. So at the very least, we need to multiply by time.delta time. That will compensate for how fast update is running. Now it won't be frame rate dependent, or not as frame rate dependent. And I think we also want to be able to vary this. Let's have a public float for it. Public float turn speed times turn speed. And that, I will remind myself, will do nothing at all yet, because our guard does not have, has their turn speed set to 0. So let's increase it to 1. In the prefab, not in any of the scenes. And nothing happens. Is this the same damn problem where the instances, the instances didn't get changed on the prefab. I think what I'm doing is, if I edit the prefab and I make a change and then I immediately click play, it does save. As you can see, turn speed is 1, but I feel like it's compiling the game and saving the prefab thing at the same time, and it's kind of up to chance which thing happens first. So I'll actually change this from 1, because I want to fix my process. Let us test if I click away from it. I think that makes it save. I think if I haven't even clicked away from the field, it hasn't saved at that point, and if I click play, then that's a problem. So let's just try clicking play then. I don't think I need to exit. Yeah, okay. And let me just check that is 2 and not 1. Yeah, they've all got 2. Okay, so if you're editing a field in a prefab, click away from it before you click play, that's fairly easy to do. Okay, that's probably a bit fast, isn't it? 1 probably was correct. Open the prefab by double clicking. Turn speed 1. And now click away. That's annoying. If you click on the window title, it doesn't get rid of the cursor, which I think means it hasn't saved. If I click on the scroll bar, it doesn't. If I click in the animation window, which you probably can't see because it's under my face. Actually, you don't have an animation window there. I've just set that up. Basically, I set up some dead space in my Unity layout so that my face doesn't obscure anything you actually need to see. All right, I don't have any good advice for where you should click after changing a field like that to ensure it saves, but somehow, I guess, what happens if I just hit Control S? Let me test that. Doing some live discovery here. I hit Control S, the cursor didn't disappear. Oh, that looks like 5, doesn't it? Okay, you just hit Control S. I'm going to hit Control S now as well, because I noticed our scene wasn't saved. Okay, yeah. After changing a value in the prefab, hit Control S. All right, but 5 is bad. What else do we want to do? I was thinking about having them move a little bit. Now, like I say, some kind of patrol point system is probably what we want ultimately. I don't want to do that just yet. So instead, we could just have them move. What happens if they just, so for following the player, we did our rigid body velocity was the vector to the player had normalized times speed. What if we just wanted to move in the direction we're facing? Well, then instead of the vector to the player, we can just use our transform.forward, our forward direction, times our speed. So this should mean they walk in circles, right? Yeah, yep, that one's seen me. So it's not great AI. Don't know if you're aware of this, but it's not bad actually, because so the most common problem with any kind of really simple wandering AI is that they bump into a wall, and if you don't specifically detect walls, then they're going to keep bumping into that wall for a long time. Why does that one lose his light for a bit? Is he tilting? Maybe he's tilting. I want to check something actually. When they are looking at me, they're... Oh yeah, so freeze rotation, their X rotation is tilted. So when we're telling them to look at us, that's overriding the rigid body's constraints. I don't really want them to tilt like that. Maybe we can fix that, since we're we're basically done, and I didn't feel like a particularly. I felt like quite a short episode. Let's see if we can stop them from tilting, because yeah, we can. What I'm going to do, because our guard, we've created them with this new rule that we create an empty game object first and we put it at 0y. Actually, we don't even need to depend on that. What we can do, if we want to only look horizontally, then rather than looking at the player's true position, which could be anything, the player could be jumping, not that the player can jump right now, but we might add that. So what we really want to do is just say, let's create a new vector 3, call it, if I call it player horizontal position, or player ground position? Yeah, player ground position. It's not strictly true, but what I really mean is it's the player's position at our height. Why don't I just call it that? Player position at our height. Why not? I don't care about long variable names. And we're creating a new vector from component parts in this case. So we do new vector 3, and then in brackets, we're going to give it 3 numbers, an x, y, and a z. And the x is going to be player position.x. The y, instead of using their y, we're going to use our y, because that's what we are talking about. We want to know, where are they on our level? Forget that they're not on our level. Pretend that they are, and just give me the x and z coordinates. So use our y coordinate, but their x and z. And then we'll look at that instead of looking at the player position. Yeah. Because I think that's why we lost the vision cone. I think he dipped. Okay, well, we certainly didn't break anything. Yeah, that's all right. And I can nudge him and stuff, and it's not breaking the vision cone. We do still lose the vision cone sometimes, don't we? Not totally sure why that is. So that the problem I just fixed is not. The problem I just fixed is not the one that was causing the vision cone to disappear. Don't know what that is yet. But what I do want to check is just, once I've got them all following me, let me just verify that I did fix the problem I wanted to fix, which is, yeah, so before we were seeing an X rotation here on the guards. Now we're only seeing Y rotation. Y rotation is the carousel one. It's the one we want. Everything else is 0. So I did fix a problem. It wasn't a problem that had any actual consequence, but still good to fix. I'm just wondering whether we should... Yeah, I think let's fix a problem that I suspect we have with lighting, because it's not obvious how to fix it. So our arena has 3 walls at the moment. I don't remember why I got rid of the other wall. I'm going to put it back. And while I'm at it, I'm also going to duplicate a wall, and I'm just going to use this rectangle tool up here to scale it to some kind of just a thing that's going to obscure vision. Obviously, when we make proper levels, we're going to need stuff like this that blocks line of sight. We're not going to manage blocking line of sight today, but I do just want to create that. And then I'm going to, what's our ground material? Let's duplicate that, Control D again, and I'll call this I don't know what, obstacle material, and all I'm going to do is just change its color basically. It could be green, and then go to this west wall to rename it to obstacle. I guess I should rename west wall 1 to east wall, because that's what it is. And I want this to have our new obstacle material. Okay. Its only job is just to be seen. I just need to be able to see where it is. And I think we will have some problems. Yeah, there's a problem. That light is shining right through it, isn't it? So, which guard is this? Can I click on them? It's guard 2. Let's look at their light. And I'm aware I'm making changes to an instance here, so they're not going to apply, and I'm making them at runtime, so it's not going to apply to the prefab or anything. But I just want to show what values we need to change here. So for one thing, shadow type is set to no shadows. Let's have hard shadows. Oh, that fixes it. But actually there's a couple of other things here. And one of them is, I think, let me see. Okay, so this is like leaking under the thing a bit. Let me see if I reduce bias. Yeah. So I don't really know what that is. I don't know why you'd want that feature. But that bias bar, if you make that 0, you get cleaner, like more correct shadows. I mean, we want hard shadows. We don't want anything to leak. Even if you wanted light to leak, that did not look like, it wasn't like diffuse lighting, you know, where it fades out like it is on the other side. It was just wrong. It was just going through something when it shouldn't go through it. So that fixes that. I think that, and we'll make all these changes to the prefab as well. I'm just doing it at runtime so I can sort of see the effects. I think we will also have a problem where if they are too close to the thing, not really saying that. Let's see if we resize this. Yeah. So he's close to it. Oh, that's weird. In scene view, I'm not seeing it, but in game mode, I am. Right? You can see the red is going through the thing. And I believe that near plane is the thing that fixes that. So if I reduce near plane to 0, oh, it doesn't go to 0. You can have 0.099999. That has not fixed it, has it? Oh, it's something else. Oh, okay. I don't really know what that one is then. It isn't the full strength thing going through it. It's just a kind of shadow of it going through it. Okay, well, it's clear enough which bits you're actually seeing. If anyone knows how to get rid of that ghost of a vision cone, I'd be interested in that. Maybe the light's going under the ground or something. But I think I have seen cases where the near plane at 0.2 causes it to shine straight through a solid object, whereas at 0.1 it doesn't. So we shouldn't have any problems with the light actually being inside an obstacle because we put our light inside the enemy, right? Our light is not sticking out of us at all. We put it right inside us, and that was intentional. Yeah, it seems like if a light is inside of a collider, or sorry, not a collider, but a mesh renderer, it will shine out of it, no problem. The inside walls don't block light, but light coming in is blocked, I think. So let's just make those changes to our prefab. It was bias to 0 is the main one. Well, hard shadows, bias to 0, and reduce the near plane as much as it will go. So we open up our guard, find their light, and where it says no shadows, we say hard shadows. Where it says bias 0.05, 0 please. And near plane is as low as it will go. And then Control S to save and play. Yeah, that's behaving reasonably well. Yeah, without those settings, obviously we weren't getting any shadows at all. Yeah, I've mentioned this a few times now, we don't actually have any code to stop them seeing us through walls. It just looks like they can't see us through walls, or at least their light doesn't hit us through walls. But we'll deal with that next time.